Dear learners, hello and welcome to this session on the Pass model of intelligence. In this session, we will explore one of the most influential modern approach to understand human intelligence. Unlike traditional theories that focus on a single score such as IQ, the Pass model looks at intelligence as a set of interconnected processes that work together to shape our ability to learn, solve problems, and adapt to new challenges. In this session, we will focus on the origins of the Pass theory, the three functional units of the brain as described by Alexander Luria, and the four cognitive processes of the Pass model. Before we dive into the Pass model, let us step back for a moment and think about how intelligence has traditionally been understood. This will help us appreciate why the Pass approach is so significant. Traditionally, intelligence has been measured through IQ tests, which give a single numerical score, and for a long time, intelligence was thought of as something fixed, stable, and measurable through a single number. Standardized IQ tests became the main way to measure intelligence. These tests often focused on skills such as vocabulary, logical reasoning, and mathematical ability, eventually coming down to a single score. But here is the problem. Human thinking is far more complex than a single number. For instance, you may know students who struggle in mathematics but are highly creative in art, or someone may have poor memory for facts but excel in problem solving and strategy. Clearly, intelligence is not uniform, it has different aspects. This recognition led to new theories that moved away from IQ as a single measure. One of the most significant among them is the Pass model of intelligence, developed in 1990s by Jagannath Prasad Das, Jack Nigleri, and John Kirby. The Pass model draws heavily on the research of Alexander Luria, a Russian neuropsychologist. Luria proposed that brain does not function as one simple unit. Instead, it operates through three functional units, each with a unique role in supporting thinking and behavior. Let us now understand Luria's idea of brain's three functional units. First unit is called arousal and attention. This first unit is located in the lower parts of the brain, particularly the brainstem and nearby areas. Its main function is to keep us awake, alert, and attentive. Without this unit, the higher mental processes simply cannot operate. Think of this unit as the power supply of the brain. Just as your laptop cannot function without being powered on, higher mental processes cannot operate without arousal and attention. For example, imagine you are in a noisy classroom and your teacher asks you to focus on one problem written on the board. Even though there are distractions, your brain filters out irrelevant sounds and focuses on the task. This is the first unit at work. Luria emphasized that appropriate levels of arousal are necessary for attention to work properly. If you are too drowsy, attention weakens. If you are over-aroused or anxious, attention scatters. This unit therefore provides the foundation for all other mental activities. Without it, planning and processing cannot take place. Now let us move to the second functional unit. The second unit, Information Processing Unit. It is located in the occipital, parietal and temporal lobes at the back of the brain. Its job is to receive, process and store information from the environment. It handles two major types of processing. Simultaneous processing is number one. This refers to the ability to put pieces of information together into a whole. For example, when you are reading a sentence, you understand how the words connect to form meaning. Or when you look at a map, you see how different locations are related. Similarly, when reading a paragraph, you look at how words relate to each other to build meaning. Next comes successive processing, which means dealing with information in a specific order, step by step. For example, when you are sounding out letters to read a new word or following the sequence of steps in a math problem. In language, it helps us construct sentences in right order and articulate speech clearly. The second unit therefore deals with the core of how we process information, whether by seeing the big picture or following a logical sequence. Now the final unit, which brings everything together. Its third unit, Planning and Regulation. The third unit is located in the prefrontal regions of frontal lobes. Its function is to plan, regulate and verify behavior. This unit is like the manager of the brain. It sets goals, selects strategies to achieve them, monitors performance and makes adjustments if things are not going as expected. For example, when preparing for an exam, you decide what topics to study, how to schedule your time, and you check your progress as you go. If one strategy does not work, you switch to another. It also regulates self-control, voluntary actions, and even aspects of personality and consciousness. In other words, the third unit allows us to act intentionally, not just react automatically. So, in simple terms, the first unit keeps us alert and attentive. The second unit takes in and processes information. The third unit helps us plan, regulate and check our actions. Now here is something very important. The Pass theory emphasizes that all of these processes work within the framework of our knowledge base. This means that our past learning, memories, emotions and even cultural background influence how we process information. For example, you may be excellent at reading English texts because you have already the knowledge of English. But if you are given a Japanese passage, you may not be able to read it, not because your brain processes are weak, but simply because you lack the knowledge of Japanese. This shows that cognitive processes cannot function in a vacuum. They are always connected to what we already know. In turn, learning adds to our knowledge, which strengthens our ability to process future information. Now comes the 4 processes of Pass. From Luria's framework, Das and colleagues identified 4 processes that form the acronym Pass, P-A-S-S, planning, attention, simultaneous processing and successive processing. Let us look at each in detail. Planning. Planning is the process of deciding how to approach a task. choosing strategies, monitoring progress, and correcting mistakes. It's the most active when we face novel situations where there is no ready-made solution. Example, when solving a new kind of puzzle, you must figure out a strategy, test it, and adjust if necessary. After completing a task, planning also involves reflection, thinking about what worked, what didn't, and what could be improved next time. This process is closely related to executive functions like decision making, problem solving, and self regulation. It is mainly managed by the frontal lobes. In short, planning helps us set goals, allocate resources, and evaluate performance. After planning, the next process is attention. Attention is ability to focus on a particular input while ignoring distractions. It ensures that we are alert enough to start a task and able to concentrate for as long as necessary. Attention involves arousal, regulation, not too low, not too high, and selective focus. For example, when reading a book in noisy environment, attention helps you ignore the noise and focus on the text. Attention requires effort, especially when tasks are long or boring. It involves both the frontal brain for monitoring and the parietal lobes for regulating focus. In simple terms, attention is like a spotlight. It highlights what matters and suppresses everything else. After attention, we move to the next process, that is simultaneous processing. Simultaneous processing is the ability to combine pieces of information into a meaningful whole. It allows us to recognize relationships and patterns. In language, it helps us integrate words and grammar into coherent meaning. For example, when reading a map, you don't just see separate locations, you see how they are connected by roads, directions. This process is managed by the occipital and parietal lobes. It is essential for comprehension, problem solving, and pattern recognition. Finally, after simultaneous processing, we have successive processing. Successive processing is ability to organize information in a specific order. It helps us remember sequences, follow instructions, and understand grammar in a language. For example, when spelling a word, you must arrange letters in correct sequence. When solving an equation, you must follow steps in the right order. This process is vital for reading, decoding words, speech articulation, and math operations. It involves the frontal and temporal lobes. In short, simultaneous processing gives us the big picture, while successive processing helps us follow steps. Now that we have looked at all four processes separately, the question is, how do they actually work together? It's important to note that in real life, these processes never operate in isolation. Every activity involves a combination of planning, attention, simultaneous and successive processing. For example, imagine you're baking a cake. First, in planning phase, you select the recipe and gather ingredients. Then during attention process, you stay focused on the instructions without being distracted. Next, through simultaneous processing, you understand how ingredients combine to form the cake. Finally, with successive processing, you follow the steps in order: mixing, baking, cooling, decorating. Only by combining all four processes, you can achieve success. Assessment of pass model. Up to this point, we have examined the theoretical foundations of the pass model and its processes. However, theory becomes meaningful only when it can be applied in practice. This is where assessment plays a crucial role. The pass model has not remained an abstract idea. It has led to the development of specific assessment tools that allow us to measure cognitive processes directly. One of the most practical contributions of the pass theory is that it forms the basis for assessment tools that go beyond IQ tests. The most widely used is the Cognitive Assessment System, or CAS, first developed in 1997 by Das and Nagleri and later updated to CAS2 in 2014. Unlike IQ tests that give a single number, the CAS evaluates a learner's performance across the four processes, that is, planning, attention, simultaneous and successive. The results provide a profile of a learner's strengths and weaknesses. For example, a child with strong simultaneous processing but weak successive processing may do well in visual tasks but struggle with reading fluency. A child with ADHD may show lower scores in attention and planning but perform normally in other areas. This makes pass-based assessment especially valuable in identifying learning disabilities, ADHD, autism spectrum conditions, intellectual disabilities, and even cognitive effects of brain injury or aging. It has also been shown to be more culturally fair because it emphasizes processes rather than language-heavy content. In short, CAS and CAS2, CAS and CAS2 give us a dynamic picture of how the mind works. Rather than just a static IQ score, and more importantly, it gives teachers practical ways to support them. This brings us to the educational implications of the pass theory. Educational implications of the pass theory goes like this. Number 1, its key implication is instruction based on cognitive abilities. Unlike traditional IQ tests that emphasize only verbal or mathematical skills, pass-based assessments like CAS2 give teachers a broader view of how students learn. This allows educators to build on strengths while targeting specific weaknesses. For example, a student with strong visual spatial skills but weaker sequential processing may excel in map reading but struggle with reading fluency. In such cases, interventions can focus on phonological training while also using visual aids to support comprehension. Another important implication is supporting students with learning disabilities. The PASS framework highlights that difficulties in school often arise from weaknesses in processes like attention or planning rather than from low intelligence. Children with ADHD, for instance, may have intact reasoning abilities but struggle because of attention lapses or poor self regulation. PASS based interventions encourage strategies such as structured routines, metacognitive training, and environmental adjustments. Approaches that are more personalized and effective than traditional one size fits all methods. A further implication involves curriculum design and executive function. Since the planning process in PASS is closely tied to executive skills like problem solving, self monitoring, and organization, schools can enhance these abilities through project based learning, inquiry driven activities, and reflective practices. Finally, PASS has broader value in connecting neuroscience and education. By shifting the focus from a single IQ score to the processes of thinking, it aligns closely with modern research in brain science. This makes it a practical framework for inclusive and flexible education, where teaching can be personalized to fit individual learners. In this way, PASS helps bridge the gap between theory, neuroscience, and classroom practices. Coming to the drawbacks of the PASS theory. However, while the PASS model has contributed greatly to understanding intelligence in a more dynamic way, it has also been associated with certain drawbacks. One important drawback is the variability in its predictive value. Although research shows meaningful links between past processes and academic achievement, not all scales are equally effective predictors. Successive processing often shows strong connections with learning outcomes, but planning scores sometimes display weak or inconsistent results. This raises questions about whether all processes within the model contribute equally to educational outcomes. Another limitation lies in the influence of language and culture. The effectiveness of PASS-based assessments may vary depending on the language in which they are administered. For example, studies suggest that the link between PASS processes and academic achievement appears stronger in English than in other languages. Moreover, differences in performance across cultural groups suggest that certain subsets may require adaptation to ensure fairness. This means the model may not always transfer smoothly across different linguistic or cultural contexts. A final drawback is the limited research on certain processes. While some aspects of the model, such as simultaneous and successive processing, have been studied extensively, others, particular planning, still require deep investigation. For instance, its role in language-related tasks or higher-level academic skills remain less well understood. This gap highlights the need for continued research to fully establish the model's strengths and boundaries. However, despite the drawbacks, the overall contribution of the PASS theory to understanding intelligence is undeniable. Coming to the conclusion, dear learners, as we come to the end of this session, take a moment to reflect on this. Intelligence is not just a number. It is a set of processes that guide how we think, learn, and adapt. The PASS model of intelligence gives us a much richer, more dynamic perspective on human potential. Instead of reducing intelligence to a single score, it encourages us to see it as a living system of interdependent processes, planning, attention, simultaneous processing, and successive processing, all of which combine to shape how we learn, solve problems, and interact with the world. The value of this model lies in its holistic view. Planning teaches us to set goals, monitor progress, and make adjustments. Attention trains us to filter distractions and focus on what matters. Simultaneous processing allows us to see connections and patterns, while successive processing ensures that we can follow sequences and rules in an orderly way. Each of these abilities contributes uniquely, and together they form the foundation for lifelong learning. Most importantly, the PASS framework reminds us that intelligence is not fixed. Every learner has strengths that can be nurtured and weaknesses that can be supported. A student struggling with attention may still have excellent visual, spatial, or problem-solving skills. Another with difficulty in sequencing may excel in creativity or planning. By recognizing these unique cognitive profiles, we move away from one-size-fits-all education and towards inclusive, personalized learning. The educational implications of this model are far-reaching. Teachers can use PASS-based assessments not just to identify learning difficulties, but to design targeted interventions, create supportive environments, and cultivate executive functions such as self-control, decision-making, reflection. In this way, the model serves as a bridge between theory and practice, neuroscience and classroom learning, psychology and pedagogy. At the same time, the PASS theory also challenges us to rethink our understanding of intelligence in society. By shifting focus from rigid IQ scores to flexible processes, it affirms that every individual has capacity to grow, adapt, and excel in different domains of life. It emphasizes that learning is not about comparison, but about progress, about strengthening what we already know and continuously expanding our horizons. The PASS model is not just an alternative framework for studying intelligence. It's a transformative lens through which we can view human potential. It shows us that intelligence is dynamic, multifaceted, and developmental, shaped by our knowledge, culture, experiences, and environment. It teaches us that with the right strategies and support, learners can overcome barriers, maximize their strengths, and cultivate resilience in the face of challenges. Thank you for joining this session. I hope this exploration has encouraged you to think about intelligence in a new light on that is broader, more inclusive, and empowering. Let it inspire you to see learning not as fixed destination, but as a lifelong journey of growth, discovery, and self-realization. where every challenge becomes an opportunity to strengthen our cognitive abilities and every success becomes a stepping stone toward greater potential.